Hey everyone, welcome back to another lesson in MCV4U. Today we'll be talking about the derivative of the general exponential and general logarithmic functions. And this is a continuation of the concepts that we've been covering in the last few lessons as well. So in terms of this warm-up question, it says to differentiate y is equal to 1 plus 5e to the power of negative 10x to the power of 4. And so here, dy over dx. So we'll do the outside and then we'll derive the inside. So deriving the outside, we'll bring the 4 down with 1 plus 5e to the negative 10x to the power of 3. Derive everything that's on the inside. So the derivative of 1 is 0. And we have 5e power of negative 10x. And then we have to derive the exponent as well. And that will be negative. So here we can simplify. And so when we simplify, we can multiply the 4 by the 5 and the negative 10. So it'll give us negative 200 e to the power of negative 10x. And we still have the 1 plus 5e to the negative 10x to the power of 3. Here, if we make it so that they're all positive exponents here, we'll get negative 200 over e to the power of 10x, 1 plus 5 over e to the power of 10x, and that's all to the power of 3. Okay, so let's look at the derivative of the general exponential function here. So the first theorem that we're going to look at is if y is equal to b to the power of x, then dy over dx is equal to b to the power of x and ln b. So b to the power of x ln b. So here, if we look at the proof, so if we take y is equal to e to the power of x, and here, the first thing if we do here, we take the ln of both sides. If we take the ln of both sides, get ln y is equal to ln b to the power of x. And here we know that with the power law, we can bring, so power law, we can bring the x down from the ln b to the power of x. So here we have ln y is equal to x ln b. And here we can differentiate implicitly. If we differentiate implicitly, we'll get here 1 over y dy over dx is equal to ln b. Here, so we would get dy over dx is equal to y ln b. And so here, if we take that and we sub that back into the y value, and here we'll get dy over dx is equal to b to the power of x ln b. So here, that's our proof, again, that the derivative of b to the power of x is equal to b to the power of x ln b. Our second theorem here is that if f of x is equal to b to the power of g of x, then we'll get similar thing here, except then we have to derive the inside, which would be the g of x. So here we get b to the power of g of x ln b, and then the derivative g prime of x. So here, notice if b is equal to e, we get the derivative from the natural exponential function. Okay, so let's look at some examples here. So we have f of x is equal to 3 to the power of x. And so here we have f prime of x is equal, so using the theorem that we just learned above, we have 3 to the power of x ln 3. Okay, and then the next one here, we have y is equal to 2 to the power of negative x to the power of 3. And so we have dy over dx is equal, so 2 to the power of negative x to the power of 3, and we have ln 2, and then also the derivative of negative x to the power of 3, which would be negative 3x squared. So there, it gives us negative 3x squared. So we're putting this into positive exponents, ln 2 over 2 to the power 2 to the power of x cubed. If for c here, we have f of x is equal to 4 to the power of x plus x to the power of 4, all to the power of 3. So here, again, we do the derivative of the outside and then the derivative of the inside. Here we have f prime of x is equal, so the derivative outside, so 3, bring the 3 down. We have 4 to the power of x plus x to the power of 4, the power of 2. And the derivative of the inside, so here we have 4 to the power of x ln x. So that's 4 to the power of x, that's the derivative there, plus ln 4, plus the derivative of x to the power of 4, which would be 4x to the power of 3. Okay, let's look at this next one for d. We have f of x is equal to x squared 2 to the power of x. So here we're going to use the product rule to derive this. So here we have x squared, and we have 2 to the power of x. So here we have prime of x is equal, so, so we have 2x, so the a prime, and then b would be the same, which would be 2x here, 2 to the power of x, sorry. And then plus a stays the same, so that's x squared, and then the derivative of 2 to the power of x. So here we have 2 to the power of x and ln 2. And here, if we pull out a common denominator of x, 2 to the power of x, then we'll be left with 2 plus x ln 2. Okay, let's look at this last example here. This last example, we have y is equal to 10 to the power of square root e to the power of x minus x squared. So here we have dy over dx is equal. So again, we're using the same idea. We have 10 to the power square root e to the power of x minus x squared. And here we have ln 10. And then we have to derive the inside. So again, e to the power of x minus x squared, all square rooted, we can understand that to be e to the power of x minus x squared to the power of 1 over 2. So we have to derive that as well. So we'll have 1 over 2 e to the power of x minus x squared to the power of negative 1 over 2. And then we have to derive the inside of that as well. So the inside would be e to the power of x minus x squared. And so that will give us e to the power of x. The derivative of that is just e to the power of x. And the derivative of x squared would, or negative x squared would be negative 2x. So here, if we just rewrite it so that we have everything in positive exponents, we have 10 to the power of square root e to the power of x minus x squared ln 10 e to the power of x minus 2x all, all over 2 e to the power of x minus x squared to the power of 1 over 2. Okay, so here, if we look at the derivative of the general logarithmic function, so if y is equal to log base b of x, then dy over dx is equal to 1 over x ln b. And remember here, x has to be greater than 0. Okay, so the proof here, again, if we start with y is equal to log base b of x, here what we'll do is we'll use the change of base. And so here we'll use a change of base. So here we get y is equal to ln x over ln b. Here we have our constant coefficient. We can rewrite this as y is equal to 1 over ln b multiplied by ln x. So that's the same thing as ln x over ln b. Again, this would be our constant coefficient. And then here we can find our derivative. So here we have dy over dx is equal to 1 over ln b, and the derivative of ln x is 1 over x. And so here we see that that equals to 1 over x ln b. And so also again here, when we look at this theorem, so if f of x is equal to log base b of g of x, then f prime of x, same kind of idea there, except we have to derive the g of x or whatever's in the inside. So here we have 1 over g of x ln b g prime of x. So here, notice if b is equal to e, then therefore, again, log base b. So if b is equal to e, and therefore log base b of x is replaced with ln, then we get our derivatives from the natural logarithm. Okay, so let's look at these examples here of the theorems that we just learned. So here we have y is equal to log base 8 of x. So here we have dy dx is equal to 1 over 8, or sorry, x ln 8. Here for b, we get y is equal to log base 2 x squared to the power of x. So here we have dy over dx is equal to 1 over x to the power of 2 to the power of x ln 2. And then we also have to derive the g of x, and in this case it would be x squared 2 to the power of x, and we have to use product rule there. So here we get 2x 2 to the power of x plus x squared 2 to the power of x ln 2. Okay, so let's try to simplify this a little bit here. So here we have x and 2x, so we factor out x and 2x, and here we'll be left with 2 plus x ln of 2 over everything that's on the bottom, which was x squared 2 to the power of x ln 2. And so here, we said we can simplify the x and the 2 to the power of x. And so our final answer here will be left with 2 plus x ln 2 over x ln 2. Okay, let's look at C. So here we have y is equal to log of ln x. So here we have dy over dx is equal to 1 over ln x. And remember, when we don't have anything written, that's going to be log base 10. So here we would write ln, and then we have to find the derivative of ln x, which is just 1 over x. So if we rewrite this, we get 1 over x ln x ln 10. Okay, and let's look at d here. So d, we have f of x is equal to log base 7, 5, log base 7 of 5x cubed minus 2x. And here to start, we can use our log laws. And we can rewrite this so it gives us 4 log base 7, 5x cubed minus 2x. And now we can find our derivative. So here we have f prime of x is equal to 4. So 4 is on the outside. And here we'll find the derivative of d log base 7, 5x cubed minus 2x. So we have first, we have 1 over 5x cubed minus 2x. And here, ln 7. And then the derivative of the inside. So the derivative of 5x cubed minus 2x give us 15x squared minus 2. Okay, and let's simplify this. So here we'll have 4, 15x squared minus 2 over x. So we'll factor out the x, 5x squared minus 2 ln 7. let's move on to this last question and a bit of a challenger question here. So here we have y is equal to log base 5 cubed root e to the power of cube root x minus 4x squared. First thing we're going to do here is we're going to rewrite it so that exponential form. So we have log base 5 e to the power x power of 1 over 3 minus 4x squared all to the power of 1 over 3. Using our log laws or the power rule here, so we'll move that the 1 over 3 to the front. We'll get 1 over 3 log base 5 e to the power of x to the power of 1 over 3 minus 4x squared. And then now we can find our derivative. So here we have dy over dx is equal to 1 over 3. Now we'll find the derivative of log base 5 e to the power of x to the power of 1 over 3 minus 4x. So first thing we do, again, 1 over e to the power of x to the power of 1 over 3 minus 4x squared. We'll have to find the derivative, the inside. So e to the power of x to the power of 1 over 3 minus 4x squared. And so e to the power of x to the power of 1 over 3 and then derivative of e to the power of, sorry, e to the power of x to the power of 1 over 3, then we have to find the derivative of x to the power of 1 over 3, which will be 1 over 3 x to the power of negative 2 over 3, and then find the derivative of negative 4x squared, which would just be negative 8. So now here we can simplify this a little bit. So we have 1 over 3 e to the power of x to the power of 1 over 3 minus 4x squared. And we have e to the power of x to the power of 1 over 3 over 3x to the power of 2 over 3 minus 8x. Here, if we continue on, simplify, we can rewrite as 1 over, so 1 over 3 and e to the power of x to the power of 1 over 3 minus 4x squared. And here we can simplify it by finding the common denominator of 3x power 2 over 3. Again, e to the power of x to the power of 1 over 3 minus 24x to the power of 5 over 3 over 3x to the power of 2 over 3. Finally, putting it all together, multiplying the top and bottom, we'll get e to the power of x to the power of 1 over 3 minus 24 x to the power of 5 over 3 over 9 x to the power of 2 over 3 e to the power of 1 over 3, or sorry, e to the power of x to the power of 1 over 3 minus 4x squared. And that will be our final answer here.